So we'll start now. Hello everyone, and well, it's a warm welcome to everybody, not only in Brazil but all around the globe, and also our friends from Israel. And welcome to this webinar, another webinar being promoted by the Brazilian Technion Society. We'll be discussing the importance of the technological innovation for the success of this new legal framework of sanitation in Brazil, and also how technologies developed by the Technion can contribute to the objectives of universal basic sanitation and water treatment in Brazil. My name is Salo Rappaport. I'm Executive Director of Associação de Amigos do Technion Brasil, also known as the Brazilian Technion Society. The Brazilian Technion Society is among several Technion societies around the globe, which is to instill support within Brazil's public in general for the Technion Institute of Technology in Israel and its activities. With our activities in Brazil, we hope we can bring Brazilian people, institutions, and even corporations closer to the Technion, and so promote exchange programs and research cooperation projects and enduring relationship among them. We also aim to help undergraduate and postgraduate students who may have an interest in attending one of the most prestigious technology universities of the world. In doing so, we at the Brazilian Technion Society will be contributing with Brazil society by creating productive and long-term relationships between Brazilian institutions and the Technion. As you all know, the Technion is consistently ranked among the world's top science and technology universities. It was Israel's first university, founded in 1912, having Albert Einstein as one of its founders. So well before the founding of the State of Israel. It's hard to distinguish the history of the State of Israel itself from the Technion. And if today we recognize Israel as being the startup nation, it owns not a small part to the Technion. With 18 academic departments in engineering, natural science, architecture, and medicine, the Technion Institute is the powerhouse of technology and innovation in Israel. And I have to say, the Technion graduates founded and lead 2/3 of Israeli companies on NASDAQ. And just to remind all of you that in the end of this webinar, I'll have the chance of post information as to know how you can contact us and learn more about Technion. So to start, I would like to introduce one of our panelist coordinators, that is Shaul Shashoa. Shaul, Brazilian born, is a Technion alumnus with a Bachelor of Science in Computer Engineering and an MBA in Innovation and Entrepreneurship. Shaul is a member of the board of the Brazilian Technion Society and is bridging between Israeli technologies and the Brazilian market. He's also involved in water treatment projects in Brazil using Israeli advanced technologies. So I'd like to welcome Shaul and ask you, Shaul, to present our other special guests of today's webinar.
Okay, Salo, thank you very much for inviting me to moderate this panel. This is a very important issue for both Brazil and Israel, and for me in particular. So I will present our distinguished guests here, the panelists that will speak. Everyone will give a small lecture, and then we will open it for open questions. So first of all, we have Miss Cristina Zuffo, Superintendent of Research, Technological Development and Innovation at SABESP, the water and wastewater company of the state of São Paulo. We have also Claudio Monken, Senior Director of Engineering at BRK Ambiental, one of the biggest Brazilian private water and wastewater companies. Also from BRK Ambiental, we have Giancarlo Ronconi, Water and Wastewater Industry Technology and New Business Director. And from Israel, the Professor Moris Eisen, Dean of the Schulich Faculty of Chemistry at the Technion, the Israel Institute of Technology. So we welcome everybody, and we will start with the lecture of Cristina.
Good afternoon, everyone. Let me put the presentation here.
Cristina, do you want me to share? Okay.
No, it's not necessary. Do you see my presentation?
Yes.
Okay. So, good afternoon, everyone. First of all, I would like to thank the Brazilian Technion Society for the invitation, and I hope to be able to pass on a little of SABESP's vision of innovation and its barriers and challenges. I would like to introduce SABESP so that you understand the complexity of the challenges we face in providing quality water and sanitation services to a large number of people from different problems and realities in a regulatory environment. Moreover, the amount of investments to implement the basic infrastructure needed to guarantee a quality operation in a state like São Paulo. SABESP is a public and private company, which its shares are on the São Paulo and New York stock exchanges, and operates in 375 municipalities, which is equivalent to 67% of the entire population of the state of São Paulo, being the fourth largest sanitation company in the world. SABESP has around 28 million customers, where 21 million are concentrated in the metropolitan region of São Paulo, as seen in this red spot here. Okay. On this slide, we can see the amount of investments made by SABESP in the last 22 years. It's important to note that about 30% of everything that is invested in water and sanitation in Brazil is carried out by our company. Another important point is the fair issue. We are subject to a regulated environment, so the tariff must follow well-defined criteria and is established by the regulator. We have the 6th lowest fare in Brazil, and it is important to note that we are one of the few public sanitation companies in Brazil that bases all its investments with fair resources without any type of government contribution. So, we have large water treatment plants, as in this photo of the Cantareira water treatment plant, that serves around 10 million people. We have large sewage treatment plants, such as Barueri sewage treatment plant, with a treatment capacity of 16 cubic meters per second, serving around 13 million people. We have very rich cities like São Paulo and like Santos, where tourism is very strong. But we also have a huge social contrast, where we have situations of extremely wealthy alongside extremely poor communities, such as Beverly Hills and IT side by side. Here, do you see Paraisópolis slum and Morumbi district, for example. Or this picture that shows irregular occupations with low-income population along important public water sources. Or even this one that shows irregular steel houses in a region of environmental protections. Here, in this case, a mangrove. So, considering these realities explained before, how can we accelerate the implementation of water and sanitation in Brazil? We need to guarantee integrated actions for short, medium, and long term. Constant action by sanitation companies are necessary, such as constant improvement of operation and maintenance, implementation of basic infrastructure, and management of available resources. And also actions by other players that directly impact the sanitation sector, such as integration between institutions, like municipalities, states, regulatory agencies, universities, financial agents, and others. Public policies for land and use and occupation. Urban solid wastes, environmental education, reduction of social inequality. So, we apply innovation as an accelerator of these changes. Now, I will talk a little about innovation in the company. SABESP uses the concept of open innovation and its activities cover technologies readiness levels from the 1 until 9. So we have projects for basic applied research, technological development, pilot tests, and validation until the dissemination of innovation. For each phase of this role, we carry out a different type of partnership, such as university startups, development agencies, and others. However, we have many barriers to innovation. Here are some of the most important ones. So first, low tolerance to failure. In Brazil, there is still a culture of repeated failures. So that makes people more resistant to change. Associated with this fact, we have the legal issues that makes the climate even less favorable to innovation. 2, developers and suppliers with a view only at technology and not dedicating the search of the most suitable technology for the problem. From the customer and business perspective, a macro view of the entire system is necessary. 3, low quality and availability of qualified personnel and service provision. We need to improve professional training a lot. 4, regulated environment. We have a regulated environment, so technologies must be in line with the Brazilian reality in terms of cost and benefit. We are often unable to implement excellent technology because the costs are outside the fair standards. We have several examples, such as smart hydrometers or smart grids, where the values are still very high, not making their implementation feasible. We ended up using that only in large consumers. For example, a traditional hydrometer cost about 50 reais, while a smart hydrometer costs 500 to 1,000 reais. Remembering again that we are in a regulated environment. 5, new technologies against traditional technologies. This is a big issue. Innovation must be competitive in relation to traditional solutions. 6, technologies compatible to different Brazilian social realities, like slums, poor communities, middle class, upper class. As I showed in the previous pictures, many times we cannot adopt the same technology in all solutions. We have social fares and many problems in some places like robbery, fraud, or misuse of materials and equipments. 7, difficult in transposing scientific academic knowledge in market innovation. It's a worldwide question. However, in Brazil, we have the aggravation of not having specific public policies and financing of this phase of development. 8, tropicalization of technologies and application. It is very important to test any technology for tropicalization. This is a fundamental point for SABESP. We have several examples of imported technologies that were implemented and did not work due to problems ranging from the simplest to the most complex. A funny and very simple example was the purchase of flotation equipment. When it started to work, the equipment began to overheat. One of our technicians noted that there was a protection covering the machine and called it the headquarters. Can this protection be removed? They said, of course, yes. This was a snow protection. In Brazil, it's not snow. 9, network for maintenance and supply of spare parts in Brazil. We need national representatives. If companies want to enter the Brazilian market, they should seriously consider this aspect. We had technologies that fell out of use because they didn't have national representatives, mainly for spare parts and maintenance. How can we be agile to keep the technology operating if we have to make international purchases whenever an intervention is needed? It's complicated. 10. What ways to acquire proprietary technologies in public purchases? This is an aspect that impacts mainly on public sanitation companies. We are working hard to overcome this barrier with the legal and supervisory bodies. 11, high bureaucracy shifts the focus of innovation to be concerned with legal, tax, and other requirements. And finally, 12, Brazilian innovation legislation. Brazilian innovation legislation is at a very early stage. Furthermore, innovation is not a priority in Brazil. Finally, I would like to show you some of our main challenges. Water resources, degradation of water resources. As you can see in the pictures, we have a big problem with irregular low-income occupations around important water sources. Climate changes. In 2014, we had the biggest drought on record in São Paulo. We never imagined that one day this could happen in a system as big as this Cantareira system. Cleanup of rivers and small streams. Although SABESP is not responsible for water resources, it works in rivers to guarantee our water resources. Recovery of reservoirs, odor and taste in water. Receiving domestic sewage from public water sources produce nutrients that produce algal blooms that can result in taste and odor in the water. Another challenge, water treatment. New technologies for water treatment. Due to the degradation of water resources, we need more and more efficient technologies. Water treatment plant solid wastes. Elimination of taste and odor in water. Here again, why? Because if we were unable to act on the first barrier, the reservoirs, we must act at the treatment station to guarantee water storage, transmission, and distribution. Smart grid for water supply systems. Detection and reduction of water losses. SABESP invests millions of Brazilian reais in fighting and detecting losses. Detection and fighting illegal connections. Internet of Things to measure consumption and reduction of water losses. Another point, wastewater collection, conveyance, and treatment systems. New technologies for wastewater treatment. Urban and industrial water reuse. Use of biogas. Currently, most sanitation companies burn biogas and do not use it as energy. Wastewater treatment plants solid wastes. This is a huge problem for the sanitation companies due to the high costs of transportation and sludge disposal in landfills mainly. Moreover, many of the available technologies are not feasible yet. Measurement and control of wastewater collection and treatment systems. In Brazil, there is no culture of sewage measurement. Reduction of odor in wastewater conveyance and treatment systems. Wastewater treatment for small communities. Customers, easy payment by customers. Innovation to calculate consumption. Customer experience when dealing with SABESP. And finally, energy efficiency and automation. Circular economy. We are working hard to implement this concept in the company. Automation, energy efficiency. SABESP's second cost is energy. We expend around the 1 billion reais a year on electricity. And finally, use of different energy matrices. Well, that's everything I want to say. Thanks for listening. I'm open for questions. Thank you.
Thank you, Cristina. Thank you very much for this really amazing presentation. You brought very interesting points and you know, show us the reality of when we talk about bringing innovation and dealing with such challenging issues. So really very much. Thank you very much.
Thank you.
I will ask now Claudio and Giancarlo. Claudio, you will start and Giancarlo will follow you.
Yes, correct.
And just I will ask the participants, you can post your questions in the chat or Q&A and we will bring in the end some of them to the panelists. Thank you.
Okay, thank you, Shao. Claudio and Cristina, congratulations for your presentation. Very good and very comprehensive overview. I will share with you and AMBO. You see that some of the challenges are very similar to SABESP in a different scale. We are a much smaller company than SABESP, but we are the biggest private company in the sanitation business in Brazil. So moving to the next slide, I give you an overview of BRK. So we are, since 2017, part of the Brookfield's Canadian company platform in Brazil in the sanitation business. We are acting in 12 different states in Brazil, now 13, as we were successful in the latest competition for the state of Alagoas. So we have a net operating revenue of 2 billion reais. We have 22 different SPEs, special purpose enterprises in the different states, more than 100 municipalities, and approximately 15 million people as our equivalent population serviced by our company. And over 5,500 employees in Brazil. So we operate, you know, Brazil is a continental country, continental size. We operate from the very north of Brazil in the state of Maranhão. Do Sul. A little bit different from the area that SABESP operates. SABESP is more concentrated in the state of São Paulo, which is the biggest state in population. We are really spread across Brazil in different states, different areas. For example, we have areas with a density of more than 500 inhabitants per square kilometer, which is similar density that demography that you have in São Paulo, to areas with less than 4 inhabitants per square kilometer in the more remote areas of Brazil. So next slide, please. Here are some of the innovation initiatives that we have been recognized nationally. Really, we are really a company that is looking for innovation opportunities, and Giancarlo will cover a little bit more our innovation framework later. Next. And here, an overview, you can see an overview of all the areas that we cover. So we have areas where we have up to 2 million people population. We have different coverage, some of them wastewater, just wastewater or just water services, or both, like an integrated concession. And it's important to emphasize we have currently 96% water coverage in our concessions. We have 83% wastewater treatment in our concessions, with a very significant growth during our period as concessionaire. And now I'll jump to the, one interesting indicator is our water loss level of 39%, comparing to Brazil is a very good indicator. So we have been improving year on year on the reduction of water losses. I'll give you the next slide, an overview, please. Next. Of Brazil and the challenge that we present in Brazil, we have in Brazil. So Brazil is the ninth largest economy of the world. And Brazil is a big, as a country, is a country full of contrasts. So you can see in the case of our wastewater, we have 35 million people without access to drinking water, potable water. We have about more than 100 million people, which is 47% of the population without access to sanitary sewer systems. So this is the sort of challenge that we are inserted as well as SABESP. And our goals as companies in Brazil is to invest in the rates that the country needs to achieve the universalization goals. And in the next slide, please. The slide is a little bit distorted, but here I would like to just to give you an idea of the, and I think it's only partially showing the slide here. I don't know what the problem is, Clarice, but
Clarice, click again, please. No. Go back.
Okay.
All right.
Yeah, but in my view here, Giancarlo, it's on top of the information. But anyway, yes. So the investments that are required in Brazil for universalization until 2033 is about 753 billion reais. We are investing, and click once again, please, Clarice. In the graph below, you see that Brazil as a whole, adding all the companies, including SABESP, which is the biggest sanitation company in Brazil, and BRK, the biggest private in the sector, we are investing about 15 billion reais in 2019. So there's a big gap. We would have to invest 4 times this rate of investments to achieve the universalization goals. So we move to the next slide in a second, and I'll hand it over to Giancarlo for us to talk a little bit about the new regulatory framework, which has been approved recently in our Congress, which will help us as a country, both private and public companies, to improve this rate of investments. So, Jean, I'll hand it over to you, and then you can cover this part and technology, our technology fronts. Thank you.
Okay. Thank you, Claudio. First of all, I would like to thank the invitation from our new friends from Technion. We really are glad to participate here, and I'd like to thank Cristina Zuffo for her presentation. Very interesting. So, well, let's talk a little bit about the key changes that we have in this new, let's say, contest of water and wastewater here in Brazil. So, the main, I consider the main change, the key change is now all the contracts, regardless it's public or private, from regarding water and wastewater, they must include targets, must include goals, very clear goals in terms of the coverage and in terms of time. So the key or the let's say the goal that the government in this new bill established is to reach. Can you click again, Clarice? One more, please. Yes. So we need to reach 99% of water coverage in 2033. And we need to collect and treat 90% of the sewage. And there are also goals to reduce the water loss and to improve the efficiency in our treatment in terms of level of treatment. So those targets is really a key change to the bill for public and private companies. Besides that, the National Water Agency, we call ANA, ANA, will be, let's say, our EPA, the agency that will give all the guidelines for the service provider. So will be nowadays we have a lot of agencies that make the regulation, but now the ANA will be the only one that will give the overall guidelines for that. And we have also to the new bids, it's going to be mandatory to have bids to make the concession. So all the existing what we call program contracts, as they end, it's not going to be renewed automatically. It has to have a concession process for bidding that all public companies and private would be able to compete and propose the better solution. So, and another way to see is this new law makes some regional blocks for concessions. So and could make this this approach much more feasible in terms of the rich areas providing value to the poorer areas. So it's going to balance this this situation. Okay, and those are what we understand the key factors that's going to make it this bill a successful one. Okay, the next slide. Clarice, next slide, please. Okay, just a minute. Okay, well, at BRK, we really understand that innovation, it's our leverage to achieve those targets. You saw in the slide presented by Monken that we really like innovation. So obviously, Cristina pointed out the barriers, very, that we have to overcome. Those are barriers that we understand that we need to overcome. So we try to make an approach of the circular economy approach. So in the key points for technical innovation, the waste or the outputs for some process could be the input for valuable additional process. So allow me to give you some examples. So one of the key points, it's the sludge disposal and treatment. So as we have this aggressive agenda for increasing the collection and treatment, the sludge production is going to be huge. So we estimate that the cost with sludge management will vary between 20 and 6% in our plants, in our systems. So we need to address that solution. And at BRK, we are looking for very different ways to transform this sludge from cost to revenue. So we are thinking in terms of application of sludge in agriculture, industrial process, of the biomass. But in order to do this, we need to implement or to introduce new techniques for dewatering, for drying, for composting. So we are working in many fronts in order to implement this in a few years in Brazil. So, and when we talk about sludge, we also talk about power, okay? Because sludge, we can produce biogas with sludge. So we lack a lot in our system. We lack the bioreactors to produce biogas. So we are also looking to those solutions. It's not really new, but there are new techniques to make more the bioreactors to make it feasible for sludge digestion and creating, developing power generation, okay? And also, at the treatment, nowadays we are looking for different ways to treat the sewage or the wastewater and trying to implement more efficient equipment in blowers and pumps, and also looking for, let's say, disruptive technologies like air infusion it's out of the box, what we used to say, that we can reduce dramatically, let's say, the capex and opex involved in wastewater treatment. Okay, next slide. So, as we saw, the collection, the current collection and treatment in Brazil, it's less than 50%. So we will go from 50% of 220 million people to 90%. So imagine the number of wastewater treatment plants that we need to develop, to implement. Okay, so at PRK, we start thinking about how to improve our wastewater treatment process. So in 2012, we were let's say, the first believers of Merida process. Merida, it's a granular sludge biomass process that we can obtain very high quality, almost water reuse quality, and with power reduction and footprint reduction. This new technology was selected as the most innovative technology in the last decade by the Global Water Intelligence. So nowadays, BRK is the largest user of Merida around the world. So we agreed with Cristina about the barriers, but in order to overcome those challenges, we will really need to be aggressive by adopting new technologies and proven ones, okay? And about the water losses, so Brazil has around 39% of water losses. So it's the same case of BRK. We have a big challenge in order to reduce that. So we estimate that as we reduce 20% to 20%, we have a net gain of almost 31 billion reais in terms of revenues for the water company. So nowadays, we are implementing new leakage detection methods and expand our smart metering devices and water digitalization in order to operate better, to reduce pressure in the net, in the grids. And for sure, in this matter, we will have a lot to learn about Israel experience. And at last, not least, well, we need to go through digitalization. Okay, so in the wastewater system, we generate a lot of data. So, and we need to use that data to improve our asset management, make it more predictable actions, and really do more with less. It's like a cliche, but it's the way that we see the digital integration in our water and wastewater system. So it's a very brief view about BRK and its challenge. So thank you so much to inviting us again. Okay.
Okay. Thank you, Marcos. Claudio. Thank you, Giancarlo, for presenting BRK and this very good presentation. And I will move on to Professor Moris Eisen, directly from the Technion, to continue with his presentation. So Moris, please.
Thank you, Shaul. Do you see the presentation?
Yeah, we can see it.
Okay. So first of all, I want to thank the Brazil Technion Society for inviting me to be part of the webinar. I know a little bit of the Brazil Society, and I know Shaul, of course, and we know a little bit of water in Israel. And I will tell you a small story because Shaul told me that I cannot speak more than 60 minutes. And so it's going to be about Israel, Technion, and dealing with water. And you have to remember, Israel is located in a place where it's a desert, not much water. So how we deal with that? So I want to show you first a little bit about the Technion. It will be not much, but we are located in Israel, a very, very small country, and we are located on the north. And as you see here, and this is the city of Haifa, and we, in front of the Technion, we see this beautiful sea. And why we see the sea? Because we are in the mountain. So this is the Technion, and it's called the Technion City. And in the Technion, we have one of the research institutes, which is called the Nancy Grant Research Institute, Stephen Grant Water Research Institute. And here we deal with some of the issues regarding water. What is this institute and why it came out to be? And the Groundwater Research Institute, it came to be a center of excellence of international caliber and the leading water research institute in Israel. The Groundwater Research Institute promotes regional and international cooperation. We are about 60 researchers from various disciplines, science, medical, and engineer, and from most faculties of the Technion. And for example, things that we deal with. So water treatment and reuse of wastewater, desalination, sanitation, water resource management and policy, preservation of water quality and quantity, hydrology, water environmental microbiology, management of urban water system, censoring losses with flux, and many, many more. Now, 1/3 of the world population have to deal with water scarcity. We know that, at least in this part of the world, and of course in many others which are arid lands. And to give an example, Israel used about 1.6 million cubic meter, 1.6 billion cubic meter of water per year, and mostly is agriculture, and then we have the municipal water and the industrial water. 95% of the water, wastewater in Israel is recycled and reused for agricultural uses. So this is very important for us. When we look based on the OECD, the organization of the Europe, the community, and we check the annual rate of population growth with the population density, we are here very high. And the meaning of this is that we need to provide clean water to a very fast-growing community with agricultural-based economy. That is Israel. Of course, we have also technology-based economy, but with fast-growing standards of living in arid regions. So how this is done, I will show you a little bit, and then I will tell you a little bit more what we do and how we do it. One of the most important issues in the government in Israel is to treat wastewater and reuse it. So that's the reason we have these plants in which you have the treat wastewater reuse. And the second is that since we are in arid areas, we cannot depend on rain. So we need to do what is called desalination, take water from the sea and use it. And this is what we do today, using membrane technology. A membrane is a plastic or a polymer that allows with pressure to get clean water from salt water. So how we do that? So we need to save water. And that's the reason in Israel, we need to be smart in irrigation. To know how much irrigation you could give and where. And that's the reason we have also sensor-based irrigation, that you could sensor the plant itself. And as you sensor the plant, you know how much water could be done. You also sensor if the same amount of water you are losing it or you're not losing it in some places of the city. Or like Christine was saying, illegal part if somebody take water. The soil aquifer treatment is the most treatment that we use. So we have the capture zone. All the cities in Israel are contained into few areas. And then it goes to a pre-treatment, the anaerobic pre-treatment, and then goes into the infiltration basins. And then it will be recovered and post-treatment and then end use. The end use will be agriculture. This is 95% of our use. But at the same time, since we don't have rain too much, we have now desalinations. And for the municipal water, we have 100% water in the 5 desalination plants. So this is the amount of water that we use in housings. And mostly also in small companies, but not in agriculture. So if this we recycle 95%, we have also for agriculture. So one of the key of success of water today from the government is that we know how to deal with fresh water. Now, when we have marginal water, we know to treat the wastewater and saline water. We know how to do that. In technology, we are good in inventing new technology. This is very, very important for us. And then having the desalinations, then we know how to save water. And what is very important in Israel is that all the water is mostly central management. So everything goes to one big decision. But let me tell you the true story. Because when you look at water, you will see that 95% of the water of the world is from oceans. And how much fresh water we have? It's about 2%. But if you look at this 2%, 68% is glacial water, and 30% is fresh groundwater. So how much water we have? We have 0.1%. This is the number of the water that we use normally. So we know, and this is a fact, that by the year of 2030, the world will have only 60% of the water it needs. And now, of course, this is if the trends continue. And we know that on every 5 deaths of children under age of 5 worldwide is due to a water-related disease. So this issue of sanitation, recycling water, is extremely important, not just for Brazil, not just for Israel, but worldwide. And we need to think how we do it smart. So now, I will not go into the scientific part, but I will tell you how we do it a little bit. So I am a chemist and I like to do polymers, plastic materials, and we prepare membranes. And I wanted to show you some of the things that membranes can offer the world. Imagine the system here. This is the membrane. And then you have many particles around here that it will eventually you want to filter. And you will see that very fast you will clog the membrane. Now let's imagine what happens if you build on the membrane these small springs, which are other molecules, and will not allow these big particles to get close to the holes, and you will continue using the membrane for filtering, but only the good water, because we are able to tailor the size of this hole. So it looks like a dream, but this is it. And the membrane here is this part, this small part in the top. That is the membrane with the spring. All this, what you see here, is to give it mechanical strength. But I know you don't believe me. So I wanted to compare. These are membranes that we prepare in the lab, and these are membranes that are commercially available from the best company. So if you take polymer 1 and you compare with this polymer, you could see that we could work at 10 atmospheres, about it like an atmosphere. That's the pressure. They were the commercial a little lower, so they are better. However, we have, look the amount of water that we get. Clean water with the same reaction. We could clean 22% of the sodium chloride. If we compare now the second polymer, working also at the same pressure, look this difference. And we are able to reject more salt than the commercial one. So first we were very happy, and then we start a company. So now we produce the polymer, and we have the membranes, and now we could have new modules to do. And this is the system that we could show for innovation. So since this start, we already continue, and since the beginning now, we are 110% better than the beginning. But that's not what I wanted to show you. I wanted to show you one application, and I could show you at least 5 or 6 applications that we know that could be interesting. We know that if you have water in some places, you have mixture of water with oil. And you want to use the water, not the oil. And the oil is a pollutant. How you clean? And you use that, you know, for example, in milk dairy products that you have in the, with the cow, you have the oils, and you have also whatever is coming out. And then you have, when you have the fruit, the apples. So you know every apple is covered with a oily material to make it very bright. And many other applications which you have water and oil. So we thought in the beginning, can we clean really the water from the oil? And this is just a one way that you could put oil in pressure without pressure, and then after time, you could see we take water with oil and we get 100%, 0 NTU, means no oil, clean water. It could be with salts, it could be with big compounds, small compounds, you get clean water. This is incredible because it's a very nice way that you could have recycling your water. So in places that you are not able to bring clean water, or at least you could recycle the water so people could reuse it normally. So now we have the models, and of course, I want to show you what we can do with that. Imagine that you have an oily, this is data that is being used from companies. So you go to an oil industrial wastewater, and then you want to clean the water. and they clean the water with commercial membranes. And then we bring the membrane that we prepare in the labs, and then you could see that in a very small amount of flux, they get already high pressure. With our membranes, they could have very high amount of flux at very low pressure. Or, for example, if you have in the water treatment, in the wastewater treatment, highly concentrated suspended solids. So we have about 3.5% better permeability to get good water, and even more and more. So the point that I'm trying to make is that we are looking for the technology, and the technology is based on problems. So when we know that we need a problem, we will find the solution because we're interested in technology. I'll give you one more example for now in these last days. We all are suffering from this coronavirus. And we know that we have to make many, many cases to check every person to see who is sick, and then we have to put him in quarantine. But there is another way faster to do that. And we already are doing it that. We found a way at the Technion in which we could check the wastewater from different streets, from the cities. So you start from the big city, and then you go from the wastewater from different streets, and then you could go to the building. And you will find with the same very fast sensor who is sick. And then in the building, you could just check on the building. So you don't have to wait for people to come. You will find it based on the wastewater. So this is the way we're trying to do. But how we do it is also very important, because we want to offer the world a better life, especially, at least for me, what is water related. However, we have the knowledge, but I want to offer you, I need you as partners. So I think that we can do a lot of things together between Brazil and the Water Research Institute, because we could have a break, we will sitting together, have a breakthrough, what we can offer, what do you need, how we could share, and having the things, developing the basic here, and then the continuation in Brazil, because this is important, because what Cristina says in the beginning, they cannot wait for buying everything abroad. But this will be a very good way to start and to be thinking out of the box. So I want to thank you for giving me the opportunity to speak a few minutes, and I will happy to answer any question that I might be able to answer. Thank you very much. Muito obrigado.
Thank you, Professor Moris Eisen, for this great presentation, really, both about what the Technion is doing and also how the technology from the Technion is transferred to the private sector and to private companies. I will now want to ask one question from all of you, both Cristina, Giancarlo, Claudio. What do you propose as the immediately next steps to start a cooperation between your companies, SABESP, BRK, and the Technion as a research institute? And also with Israeli companies that I'm sure you know much of them and their technologies. So Cristina, can you start answering?
Yes, sure. Yes, sure.
Good question.
Good question. In SABESP, we are open to partnerships for the development and full-scale implementation technologies. So it's matter of approximation only and talking about this, because we totally open to this. We have the forms and many different forms and the things that to do principally with the universities, but with companies and startups too. It's relatively easy to do partnerships in this direction.
Great.
Yes, I can. So I can talk about BRK. In our case, we are also very open to new opportunities. I think Israel and Brazil have very different challenges, especially in terms of water. But I think we have already our strategic lines of action for technology, which will help basically will help us be more efficient and be more aggressive in our expansion, the expansion of our networks. I think the biggest, we have many issues, many challenges in Brazil, but the biggest challenge, no doubt, is still that half of the population is not served with wastewater. So our main goal is to be efficient in that sense. You know, the most expensive service is the service that is not available to the public in this sense, in terms of wastewater. So not being able to reach a big part of the Brazilian population is the big challenge for us. Of course, to do that, we need to be efficient in our processes. And this is the other, let's say, line of action that Giancarlo emphasized here, how we treat our sludge and dispose our sludge, how we are more efficient to reduce our energy consumption, reduce the losses, because we believe that, and I think the same line for SABESP. The more efficient we are as companies, the more we be competitive to get new areas of concession, you know. And so I think it's just a matter of matching the opportunities and where you could support us and developing maybe a pilot in some of those areas. But definitely we are very open. We have cooperations with other organizations in terms of technology. Gian, feel free to add your perspective.
Yes, just adding up a little bit about Monken was saying, Professor Eisen, thank you so much for your presentation. We are very...
Giancarlo, please put on your video, please.
Oh, sorry. Yeah, my beautiful face. Okay, thanks. Thank you, Professor Eisen. Fantastic presentation. Well, I see, just being, let's say, very objective here, you mentioned about membrane technology and some hydrogeological experience, and for sure, fantastic experience in Israel. I visited Israel and I saw at Iguadan wastewater treatment plant the way you do in terms of the use, fantastic. So here I believe one touch point, immediate touch point would be treatment of brackish water. So and modeling of systems with a huge number of deep wells that have problems of quality and quantity. So modeling this, let's say, deep wells in a dynamic model and treating this brackish water that unfortunately we have in that city in Maceió would be a good point of contact, okay, for initial exchange of ideas.
Great. Moris?
Okay, I think the cooperation between Israel or the Technion and the Brazilian companies, it will be based in two different things. I agree with Claudio, because when you don't have water in some places, you cannot talk about recycling water. That's two different issues. You first have to bring the water. But at the same time, when you are smart using the water, then you are also smart how to bring the water to the people. And sometimes, like Giancarlo was saying now, if you could use, for example, brackish water any aquifer water and you could use it correctly, that could give you a very nice solution to some places. So this is indeed the way that, in that sense, we could help. We could help is that making a brainstorming. It's just doing brainstorming because we have, at least what I know in Israel, in one of the plants that I'm giving some advice, the water is recycled. And it's recycling in the aerobic part and the anaerobic part. The anaerobic is with some bacteria. And from that anaerobic part, we get methane. And the methane that we get, we run the same plant. We don't pay electricity whatsoever. We eventually get more energy than the one that we're putting in. So, and that water is given to agriculture. Of course, you could also clean it and use it for even better things. But let's say that people will, public opinion will not bring it up. But this is an issue that I think the best will be to have some brainstorming between whatever are the needs of the big companies in Brazil, and maybe to have, I don't know the technicals and the issues that I believe Brazil has many achievement in the water that maybe they could teach us how they do it, and maybe we could share knowledge. And maybe, like Claudio was saying, I mean, I think in this question of water, Israel and any university in Israel will be really willing to have this share with any of the companies to see how we make it better. Because they will make it better, we will make it better as well. It's a win-win situation.
I agree, and I think one of the roles of the Brazilian Technion Society is to bring this to bring Israel and Brazilian challenges and solutions together, more closer, so one can learn from the other and to bring for more and deeper cooperations. So thank you, Moris. So in order to stay in our time limit, I want to thank you very much, all of you, Cristina, Claudio, Giancarlo, and Professor Moris Eisen, for being part of this great webinar. Very interesting points. And I will pass to Salo to finish with the last words. So thank you. Please, Salo.
Okay. So I think was an amazing sharing of experience, and of course we have a tremendous challenge ahead of us when we look at how much we need to be invested, and of course technology is going to be part of it. And we also seen some very interesting questions from our audience, so we will forward them to you, and of course whenever we make these webinars happen, the idea is also to bring together our community here in Brazil. So you afterwards, you feel free really to talk to each other. We see also a very important role when we think about developing engineering and the people here in Brazil that will have to bring this innovation forward to solve these problems and this challenge. So thank you all again. I'd like to thank you, Cristina, for your excellent presentation. Cristina, was very nice hearing from you, and SABESP is, of course, a benchmark in the world when we think about sanitation. Thank you, Claudio and Giancarlo from BRK. It's also an amazing private company, and it's very nice to hear from public and from private sectors how much we've been dealing with this. Thank you, Professor Moris, for bringing some of your excitement behind innovation of Israel, which is always very nice. And of course, we hope to have moved this conversation forward. And of course, to Shaul. Shaul, thank you very much for the coordination of this panel. And to Clarice, who is our coordinator, and she's been in the backstage making everything happening. And we have also here on the stage with us, Salomon Yospi, who is the president of the Brazilian Technion Society. So Thank you, everybody. Thank you for the audience, and hope to see you in our next webinar very soon. Thank you.
Thank you
so
so
much.
Thank you too.
Bye-bye.
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 Thank you. Bye-bye.
Bye.
Bye-bye.